Hello and welcome. A little while ago, I posted a video in which I showed an observation and claimed that it demonstrated over 1,000 feet of Earth's curvature. At the time, I only had a rather poor image to show, a rather unclear photograph of these three bridges and the hills in the distance. So I was waiting until I had a much clearer image, like the one you can see on screen now, before publishing a video that explained exactly why this shows over 1,000 feet of Earth's curvature, why this particular image is completely impossible to take if the Earth was flat, and how it confirms the globe model of the Earth by matching exactly predictions from that globe Earth model. So this image, this observation, is impossible if the Earth is flat. Let's just let that sink in. I have taken a photograph, and it is impossible for that photograph to be taken if the Earth is flat. So there's only one conclusion. I've managed to make this observation. Furthermore, it can be repeated by anybody. All they need is a small camera with about 20 times zoom, and they'll be able to repeat the observation shown in this video. So given those facts, the Earth cannot be flat. Any debate about whether the Earth is flat or not is now over just because of this image. Now, it's not the only image. There have been many other images over the years that have achieved exactly the same thing, and yet there are a few crazy people who still think the Earth can be flat. But it cannot. And here is my contribution to the vast amount of evidence that demonstrates very clearly that the Earth cannot be flat. So what are we looking at here? Well, we're looking at three bridges that cross the River Forth in Scotland and some hills in the background. The height of the camera above sea level is 210 meters. The height of the central bridge tower here in the middle of the shot is 210 meters above sea level. The height of the hills is greater than 500 meters. Now, this is a 40 times optical zoom shot, and we will pan out to a 20 times optical zoom shot that will bring into view hills that are definitely over 500 meters. The ones you can see in this particular slightly more zoomed in shot here is 413 meters, and these over at the side here are around 500 meters. This, as anybody with a brain can tell, is impossible if the Earth is flat. If we have a camera at 210 meters, a bridge tower at 210 meters, then everything that appears in the image to be the same height as the bridge tower must be 210 meters above the flat plane of the Earth, if the Earth is indeed flat. Yet we have hills that are over 400 meters and up to 500 meters tall that appear to be the same height or shorter than the bridge tower. That is impossible if the Earth is flat. Furthermore, the observation you see here and the later zoomed out to 20 times zoom image matches globe Earth predictions pretty much exactly. And so it adds weight to the view that the Earth is in fact spherical. Here is a diagram of what should be happening if the Earth was flat. So the blue bar at the bottom represents a flat plane of the Earth. The horizontal scale is in kilometers and is obviously hugely compressed. The vertical scale is in meters. The hill on which the camera is located is 221 meters tall and the camera is at 210 meters. So looking across to the bridge tower represented by this grey column here, which is also 210 meters tall. And anything that lines up with the top of this tower on the hills in the background should also be 200 meters. Yet we know that the hills in the background are 400 plus up to 500 meters tall, and yet top of the tower does not line up with some point partway up those hills, but it appears to be taller than 400 meters and about 500 meters tall. As I say, the observation here is impossible if the Earth is flat. This is what the flat Earth predicts, and it is impossible to get this image if the Earth is flat. As to illustrate the point with a real-life example, I have here some soda cans. There's 5 stacks of soda cans, 2 cans in each stack, an orange one and a silver one. The camera is placed level with the top of the silver can in the near foreground, and the camera is held as level as I could hold it. The floor is level, as illustrated by this laser pointer. There's a laser level on the floor, pointing this beam of laser light to just around a centimetre above the surface of the floor, and it starts from just about a centimetre above the floor by this first stack of cans here. We can see that the top of the cans is exactly level in the image, all the way back over a distance here of around about 8 meters from the can in the foreground to the can in the background. You can place a line across the screen and the tops of the cans lines up nicely with that line. If we move the camera down so that it is no longer level with the top of the silver can, but level with the top of the orange can, then it is the tops of the orange cans that lines up and is exactly level across our image. You can see the laser pointer light still in the distance here. And the top of the orange cans lines up pretty perfectly all the way back. So the statement that the bridge, the camera being at 210 meters, the bridge tower top being 210 meters, means that everything in the distance that is 210 meters should line up with the top of the tower, is absolutely true and verified in the real world. So here's our image once again. We can draw a line across so you can see how the height of the central tower there relates to the hills in the background. These hills appear to be roughly the same height as the top of the tower. And these hills appear to be lower than the tower, even though, as I shall show in a moment, this hill here is 413 meters tall. So here is our 20 times zoom shot. Not quite as clear as the 40 times zoom, but still plenty good enough. I've identified some of the hills in the background using Peak Finder, and we'll see an overlay of the Peak Finder horizon shortly. I've given the distances to the various hills and their elevations above sea level as obtained from topographic maps and from Peak Finder. We place the line across the screen. We can see that Strong End at 511 meters lines up almost perfectly with the top of the central tower here. Central Tower is taller than Kennoch Hill and maybe a little shorter or the same height as Dunbrach and Earl's Seat. Meikle Bin and these other peaks near to Meikle Bin is the only place where the horizon, the hills on the horizon appear taller than the central tower here. Meikle Bin is the second tallest hill in the shot here that I've identified. It's closer than Earl's Seat by 10 kilometers. The fact that it's 10 kilometers closer is the reason that it is above the line on the image. And we'll see that confirmed from some globe earth predictions shortly. Here is the overlay of Peak Finder. Now the Peak Finder labels disappeared off the top of the shot here, but I've kept my labels in, and you can see that the Peak Finder label for Meikle Bin coincides with where I've placed the arrow. Peak Finder doesn't have a line for Dunbrach. It does have an orange dot, and does give you a height for Dunbrach, but it doesn't have a line for it. I've ignored some of the hills because they relate to hills that are in the foreground, much closer to the camera, and I don't think they contribute very much to the story. They match what the globe earth predicts, and the important hills I've highlighted. Kennoch Hill is here and Strong End here. I'll place the line across the screen again, and you can see how well that lines up with what we observed before. And if I fade out the overlay of the Peak Finder and bring it back, you can see that it matches very nicely the horizon that we actually observe. So there's no doubt in my mind that these are the hills in question. They match perfectly with what Peak Finder says for looking in the same direction from the same location. The location is shown here on this still from Google Earth. The camera is located on a hill called Traprain Law here in East Lothian, and looks west and just slightly north of west towards the Fintry Hills and Campsie Fell. And looking west-northwest from Traprain Law, there's a clear line of sight to the Campsie Fells and the Fintry Hills north of Glasgow. A lot of the distance is over the water. The land does poke out into the water in some locations, but it's much low-lying than Traprain Law, and much more low-lying than the hills in the distance. This is Traprain Law. It has a trig point here at the top, which is 221 meters above sea level. For this observation, I placed my camera a short distance down the hill, and I'd like to show you a few other features just to explain the observation in detail. You're still with me at this point. So going to Google Earth for a second, let's have a little look at the elevation profile of the central line. So these three lines go through each of the towers on the Queensway crossing just here. And you can see they're coming from Traprain Law. We see over a small hill in East Lothian, look along the flat water of the Firth of Forth, another low hill, some more low hills, before the land starts to climb up at the Campsie Fells and Fintry Hills here. On a topographic map, I'll just zoom out because these are the Campsie Fells and take you to Traprain Law. Traprain Law is still near to the town of Haddington. I used to live in Haddington, which is why I remembered about Traprain Law. You can see it's listed as 221 metres above sea level. That's at the point on the dot in the middle of the hill there. That's as far as we can zoom in. The contour line that runs just around here is at 210 metres. So the slightly heavier line is 200 metres, and this contour line is at 210 metres. And I walked from the peak down to a point here about this far, so that I was at 210 metres, or just below 210 metres. When I placed my tripod, the camera was as close to 210 metres as I was able to get. You can see all the way along the Forth estuary, there are the three bridges that we see in the photograph located here. The one on the left is the Queensferry crossing, which is the more recent one with the 210 metre tall tower. And the hills we are looking at in the distance have also on the topographic map been identified and have some heights. Meeklebin is 570 metres. Further in the distance, Earl's Seat at 578 metres. Dunbrack is 540 metres. It's not given a height on the topographic map, but the highest contour line here is 530 metres, and the point of the peak is at 540 metres. There's some slightly lower hills in the middle, which are directly in line with the central tower, as you noticed, and then to the right-hand side on our image is the peak of Stronend on the Fintry Hills at 511 metres. Just to verify the tower height, you will find on the internet the tower height for Queensferry Crossing listed as 206 or 207 metres. But this website that describes the construction of the towers states that the central tower is 210 metres and the north and south towers are 202 metres. And this is in good agreement with the image that I took, where the north and south towers appear slightly shorter than the central tower. So I trust this height for the towers. Now, what would we expect to see on a flat Earth? And what would we expect to see on a spherical Earth? Well, I'm using Walter Bislin's Advanced Earth Curvature Calculator because it allows us to enter objects and to see how they would appear if the Earth was flat on the left and the Earth is a globe on the right. So our target object is the bridge tower at 210 meters. I've placed the camera height at 210 meters as well. The distance to the tower is 46.5 kilometers, or 46,500 meters. I'm just going to pan this a little bit so that we can see each of the objects more clearly. In the distance, I've placed a hill 96.4 kilometers and 511 meters. This is to represent the hill Stronend. Now we can't see very clearly the objects that we've placed in the distance in this view. Hang on, I need to place that object actually in there. We now have the hill in place as well. We can't see them, but we can zoom in and get a better view of the objects. Now, on the flat Earth, we would expect to see the top of the tower quite a long distance down the hillside, about halfway, less than halfway up the total height of the hill. On a globe Earth, this particular view shows the tower being above the height of Stronend, and it appeared to be about the same height as Stronend. But we have no atmospheric refraction included here at all. If we include standard refraction, then the height of the top of the tower almost perfectly coincides with the top of the hill Stronend. And that's exactly what we observed in reality. And we can repeat this operation for various hillsides. So if we go to our second object and we place in the distance and the height for that object, Hanoch Hill was 89.1 kilometers away and is 413 meters high. Once again, on a flat Earth, we would predict the top of the tower to be roughly halfway up the height of the hill. But on a globe Earth, the top of the tower is considerably above the height of the hill, exactly matching what we saw in my observation. If we go to the Dunbrack, which is at 97.2 kilometers away and 540 meters tall, we see that on a flat Earth, again, the tower should appear less than halfway up the height of the hill, and on a globe Earth, the top of the tower should be roughly level with the top of Dunbrack, which was exactly what we actually observed. If we put in the height for Earl's Seat, the distance for Earl's Seat, which was 101.6 kilometers and 578 meters tall. Once again, the top of the hill and the top of the tower coincide almost perfectly on a globe Earth, which was exactly what we observed in my picture, and on a flat Earth we would expect the top of the tower to be much less than halfway up the hill. And finally, Meikle Bin, which is 91.8 kilometers from the camera and is 570 meters tall. Meikle Bin we would expect on a globe Earth, Meikle Bin peak to appear above the height of the tower, but not by a very large amount. And on a flat Earth, we would expect the tower to get less than halfway up Meikle Bin. So, as I stated early on in the observation, in the video, this particular observation is impossible if the Earth is flat. The top of this tower should be down here somewhere if the Earth was flat. Or, conversely, you might argue the top of the hill should be much, much higher up if the Earth is flat. I am able to make the observation, so the Earth cannot be flat. Once again, camera height 210 meters, a bridge tower height 210 meters, height of the hills greater than 500 meters, Dunbrack 540 meters, Earl's Seat 578 meters, and yet a 200 meter or 210 meter tall tower appears to be the same height as those hills. That's over 300 meters or over 1,000 feet of curvature demonstrated. This image is impossible to take on a flat Earth. So the Earth cannot be flat. It's as simple as that. You don't need a P900, you don't need a fancy theodolite or any other expensive piece of kit to be able to demonstrate this sort of thing. And I challenge any flat earther who has made it to the end of this video to do two things. Firstly, explain how this observation is possible on a flat Earth. And secondly, to go to Traprane Law on a clear day and take the image that I've taken, repeat the observation that I've made, and see whether it is in fact true. Thank you for watching, and hopefully I can get this video posted up and some other ones posted very soon.